Hi, welcome to the review for the topic 2 formative. The biggest thing we're going to do first is to read the question. A lot of times people don't read questions. They look at a problem and just start doing it however they feel like. However, in the directions, there are often little hints. So let's read first. Quadrilateral A prime, B prime, C prime, D prime is the image of ABCD after being translated 3 units to the right and 5 units down. That means this picture right here, this is what happened after I had translated. That means I'm not translating this one 3 to the right and 5 down. I've already translated it. That means I need the original image by going backwards. Because question number A asks, or letter A, plot and label the pre-image ABCD on the graph. So instead of going 3 to the right and 5 down, I'm going to do the opposite. Let's do this with each point now. So for B prime, I'm going to go 3 units left and 5 up. 1, 2, 3, 1, 2, 3, 4, 5. Okay, and we're going to label that as my original B, not B prime. C goes 3 left, 1, 2, 3, 1, 2, 3, 4, 5. That's my original C. D, go 1, 2, 3 left, 1, 2, 3, 4, 5. Oh, hey, look, that's just where B prime was. And A, 3 to the left, 1, 2, 3, 5 to the right, 1, 2, 3, 4, 5. So that is my A. So, we put the points, let's connect them. So you should see that it's the same shape, it's just been translated, it's just been moved around. So, after I plotted the points, we're just going to label the coordinates. So, remember, x first, y comes second. So let's start with A. If I'm on the x-axis, A, -3. I did not go up or down, so that's -3, comma, 0. Next is B. B is right up there. Cut off a little bit. So this point is -2, comma, 7. 1, 2, 3, 4, 5. Nope, it's not 7. It's 6. That is an error that I expect a lot of people to make if not counting it carefully. Yeah, so that's not 7. 1, 2, 3, 4, 5, 6. All right, what about C? C is 2, comma, 4. Is that 4? 1, 2, 3, 4. Yep, that's 2, comma, 4. The last one is D. 1, comma, 1. D is the same as B prime. 1, comma, 1. Moving on, the next question asks, use coordinate notation to describe the transformation of quadrilateral ABCD to A prime, B prime, C prime, D prime. Meaning, I would like the transformation from the pre-image to the image. Well, they've actually told it to us up here. It's translating 3 to the right, 5 down. So we're going to be putting that in coordinate notation. So, they've given us the first part here. We don't need to write anything else. So I've moved 3 to the right, so I'm doing x plus 3. Positive 3 on the x-axis means I move 3 right. And I've moved 5 down, so down is y minus 5. So this is coordinate notation. Right. Last question on this page asks, what's the definition of a rigid transformation? You could Google a lot of them. You're going to get some really complicated definitions. So I'm going to give you the one that I find is the most simple and the most helpful. So, a rigid transformation is a transformation that maintains the same size and shape. So we learned about 3 rigid transformations. First one was translations, reflections, and rotations. So if you notice, with all 3 of those, we did not make any of the, none of the shapes got bigger, none of the shapes got smaller, none of the shapes changed into different shapes. That's why it's called a rigid transformation. You move it around, you twist it, you flip it, but it's still the same size. It doesn't get bigger, doesn't get smaller, doesn't change into some other magical shape. So this is the most helpful definition in my opinion. The one on Wikipedia is more confusing, don't use that. All right? Next page here, reflect the point G. So on the one that I handed out you, it's A on yours, it should be changed to G. I'm using the corrected version here. So reflecting the point G across the following lines and give the coordinates of its image. So the first one says reflected across the x-axis. So the x-axis is right here. And why don't I color code this all to make it nice and visual? So I'm reflecting it across the x-axis. So this is point G. How high is it above the x-axis? 1, 2, 3, 4, 5, 6, 7. Since it's 7 above, if I'm reflecting it, it's going to be 7 below. 1, 2, 3, 4, 5, 6, 7. So that's my new G. We can call this G prime, although I would probably avoid labeling because then you'd have too many different points labeled G prime. So that's my new one. What is this? Well, what's the coordinate of it? It is 1, negative, is that negative 7? 1, 2, 3, 4, 5. Yep, it's 1, negative 7. So that's 1, negative 7. All right, this is the x-axis. I'll even put it right there. You know what it is. Next one, we're now, oh, great, we're reflecting it over the y-axis. Y-axis, let's see this in red. So the y-axis is here. If I'm reflecting across the y-axis, well, G is 1 point to the right of the, 1 space to the right. So if I reflect it, it'll be 1 space to the left. And we're going to mark this coordinate. This coordinate is negative 1, 7. So let's write it here, negative 1, 7. So these are the easy ones. Now we start to get to things that are more difficult. C asks for the line y equals 2. Well, what we're going to do is go to the y-axis. Where's 2? Right there. That means I'm going to create a horizontal line that is always at y equals 2. So this is your y equals 2 line. Oops, forgot to label this as y-axis. Cool. So this is your y equals 2 line. So we're going to reflect point G across the y equals 2 line. How high above the y equals 2 line is G? 1, 2, 3, 4, 5. So it should reflect 1, 2, 3, 4, 5 below. And now we're going to mark these coordinates. This is 1, negative 3. I'm going to go down to my paper. 1, negative 3. Negative 3. Right. Next is x equals negative 3. So x equals negative 3. Why don't we change the color to purple? X equals negative 3. Well, where's negative 3 on the x-axis? It's right here. And this time I'm creating a vertical line. Vertical, vertical. Okay, what we're doing is reflecting G across the line x equals 3. Let's label this. X equals, not 3, sorry, negative 3. How far away is G from the x equals 3 line, negative 3 line? 1, 2, 3, 4. It's 4 spaces away. So then it needs to be 1, 2, 3, 4 spaces in the other direction. The name of this point is going to be 1, 2, 3, 4, 5, 6. Negative 7, 7. Negative 7, is that 7? 1, 2, 3, 4, 5, 6, 1, 2, 3. Yep, negative 7, 7. So you go down, right? Negative 7, 7. So these are all the horizontal and vertical lines. Now we got some diagonal ones. We got y equals x, y equals negative x. Let's change to orange now. So y equals x. Well, y equals x is that lovely, perfectly diagonal line that's going from the upper right to the lower left. So, you should be crossing through all the diagonals. It wasn't as perfect, but all right, let's see. I'm reflecting this across a diagonal line. Now this is y equals x. So we can't think vertically, we can't think horizontally, we must think diagonally. How far away is G diagonally from this line? Well, it is 1 diagonal away. 2 diagonals, 3 diagonals. So you can see it's 3 diagonals away in that direction. So in this direction, it must be 1, 2, 3 as well. See? So this distance here is 3. Distance here is also 3. Right? Let me erase this inside part now. There we go. So the name of this point is 7, comma, 1, 2, 3, 4, 5, 6. 7, comma, 1. So you see I keep repeatedly counting this because this graph isn't as nice. So you can make a mistake here. 7, comma, 1. So y equals x is 7, comma, 1. Right? This last one, let's choose, how about this like nice little sea blue thing. So y equals negative x. Y equals negative x. It's another diagonal line. It's just going the other way. So y equals negative x. Go perfectly through the diagonals. While I'm doing this, my shadow's in the way, so that's hard. I would not suggest using a ruler. If you use a ruler, you may not go through all the diagonals. You might go through a few and then completely miss the rest. So we're reflecting G across the diagonals here. So how far away is G from this light blue diagonal line? It is 1, 2, 3, 4. It's 4 diagonals away from this line. So if I reflect it, it's going to be 1, 2, 3, 4. That's going to be here. Just checking if I did it right. 1, 2, 3, 4. 1, 2, 3, 4. Yes, I've done this right. So, let me erase this part just to make it nice. So, this point is negative 1, 2, 3, 4, 5, 6, 7. So negative 7, comma, negative 1. Negative 7, comma, negative 1. So this is your section on reflections, and it's also just making sure you don't count wrong. And also helping you practice your points. Okay, let's move to the third page here. All right, so I have a little picture of a clock here. This is the one that's scary. This is the rotations one. This is the most visually confusing of all the transformations, in my opinion. Now, what this is saying is the triangle ABC will be rotated 270 degrees clockwise about the origin. Now think about the hands of a clock. I even copy pasted a picture from the internet here. Clockwise means I'm going that way. That means this triangle moves 270 degrees that way. So that means it's going to be moving from here, 90 degrees, 180 degrees, and then 270 degrees. This triangle is a little bit harder than the ones we practiced in class because one part of the triangle is in one quadrant, the other part of the triangle is in another quadrant. So this one's actually very visually confusing. So the way I explain this in class is actually rotate the image. If this is the image the way it should be, and we're going to rotate it clockwise, and I actually did some cool technology stuff here. So I'm actually going to rotate it 270 degrees clockwise. So I'm going to rotate it. Right, so this is 90 degrees right here. This is 180 degrees upside down. And now that is, that's 270 degrees. So if I rotate it, it's going to look like this. Meaning you have to pretend that this is the y-axis, this is the x-axis. You have to pretend that it's regular now. So I'm kind of cheating here, but this is how you need to think about it. Well, if I'm going to plot the new image, then let's think. Where's my B if I pretended this was upright? That would be 2 left and 3 down. So I'm going to go 2 left, 3 down. That will be my B prime. What about my A? A is 1, 2, 3, 1, 2, 3, 4, 5, 6. So I go 1, 2, 3, 1, 2, 3, 4, 5, 6. So that is my A prime. Finally, C, it is 1 to the right and 1, 2, 3, 4, 5 down. 1 to the right and 1, 2, 3, 4, 5 down. And that is my C prime. So this is my triangle rotated 270 degrees. 270 degrees clockwise. You can also take a shortcut. Remember, 270 degrees clockwise is the same as, we can say, or 90 degrees counterclockwise. You could have gone in that direction instead. So let's actually take a look at this image upright again. So this is the original image. I made a copy of the image so I can actually show the rotation. If I rotate it 90 degrees, then 180 degrees, and then 270 degrees, doesn't the triangle on the right now look like the triangle I drew on the left? That is what you need to be drawing. You need to imagine this image has been rotated 270 degrees and draw where it's supposed to be. It's just that now you have one graph you have to do it on instead of two. So let's move the original image out of the way. Okay, now let's answer some of the questions. So, okay, what are the coordinates for the image? Well, now that I drew it, I just need to label the coordinates. This is just understanding the coordinate plane. So my A prime is 1, 2, 3, negative 3, and 1, 2, 3, 4, 5, 6. Negative 3, negative 6. B prime is 1, 2, 1, 2, 3, negative 2, negative 3. And C prime is 1, comma, 1, 2, 3, 4, 5. 1, comma, negative 5. Right? Right, so we got some thinking questions below. Which quadrant of the coordinate plane will contain vertex C prime? Well, I rotated it, and where's C prime in? So if you forget the quadrants, this is quadrant 1, this is quadrant 2, this is quadrant 3, quadrant 4. We use Roman numerals so we don't get these confused with the actual numbers on the screen. So, where is the new C? C is now here. That is considered quadrant 4. So which quadrant? This is quadrant 4. All right, and this last one here. A, B, C were rotated counterclockwise instead of clockwise. Which quadrant of the coordinate plane would contain vertex A prime? So this is actually where I'm going to go to my original image. I'm actually going to think about it. What if I rotated it counterclockwise, meaning going the other way? So if I rotated this counterclockwise 270, so that means I'm going 90, 180, oops, and 270. All right, so they were asking for point, or vertex what? Vertex A. So where's vertex A if this were a regular coordinate grid? Well, we're going to treat this one as 1. So it actually will rotate into coordinate quadrant 1. So there we go. So the answer is quadrant 1, because if I rotate the picture, it will be in quadrant 1. You just need to imagine that this is your original, this is the right side up. So moving it down, the answer is quadrant 1. Roman numerals are nice. Okay, we got one last page now. So, on yours, there was a mistake. That's my fault. So, this should be negative 3x plus 2. So change that if you have not. All right, so that's the equation graphed here. What we're going to do is we're going to reflect the line across the y-axis, and then sketch the graph of the image, and then write the equation. Right, so what we're going to do first is on the line, if you want to reflect it, it's hard to reflect a full line. It's nicer to just reflect points. So I'm going to find nice points of the graph. So you want to find the point like this, this. Don't use this. That's not going to help you. So I got 1, 2, 3, 4 nice points. And let's reflect it across the y-axis. The y-axis is right here. Just changing colors to make it easy. If it's 1 to the left of the y-axis, it should be 1 to the right. If it's on the y-axis and reflected, it needs to stay on the y-axis. If it's 1 to the right, it reflects 1 to the left. If it's 2 to the right, it reflects 2 to the left. So I'm going to connect my line now. So this is my reflected image, what I've drawn in blue. So I've sketched the graph. Now I need to write the equation. So the best way to write the equation here is to use y equals mx plus b. That's all from algebra 1. So y equals mx plus b. So that means I need to figure out what is my m and what is my b. So remember, your m is your slope. So the slope is, we often called it the rise over the run. So what it really is if I have one point on my line, what movement do I need to make to get to the next point? So I'm going to pick this point down right here. So in order to get to this point, what is my movement? I got to go up, 1, 2, 3, and right, 1. Up 3, right 1. Or if I go it again, up, 1, 2, 3, right 1. So you go up 3 and right 1 every time. Therefore, your slope is 3 over 1. Now, 3 over 1, that just means 3 divided by 1. So that's just 3. You don't need to write that 1. That 1's just more writing. But you can leave it like this. It's okay. I would prefer it as just a single number 3. And then now we got to find the b. Or the b is called the y-intercept. Meaning, when does the graph that I drew cross the y-axis? So the graph that you drew was the blue line. When does it cross the y-axis? It crosses it at there. That is at 1, 2. So my b value is 2. Coincidentally, both graphs cross the y-axis, but yeah, b is 2. So take all of this, plug it back into this equation. So y is the same. Y equals m. Instead of m, I write 3. So y equals 3. X always stays as x. X and y are always in equations. Plus b. My b is 2. Remember, if your b was down here, let's say your line looked like that. That's negative 1, 2, 3, 4. Then you would put minus 4. But since this is above the x-axis, you call it plus b. Okay. Moving it down. The graph shows the equation and its image after a rigid transformation. Identify 2 different ways to describe this rigid transformation. So, first thing, there are 3 rigid transformations. There's translations, reflections, rotations. Well, this is certainly not a translation. Translation only moves it left and right. Also, this is the original. 3x minus 3x plus 3. This one's the original. This is my new one. You can clip it to sticker. So, well, it's definitely not a translation. Translation means I move it left, right, up, and down. It possibly could be a reflection, but it's not a simple one. It's not a reflection over x. It's not a reflection over y or any of the other lines. I don't think I could personally tell what type of reflection this is either. So the way we want to describe this rigid transformation is actually via rotations. So if you look here, you see how the y-intercept was that? Well, guess what happened? It moves there. So what kind of a rotation is that? I've moved it from this to here. That is actually a 90-degree, let's think. This is clock. This is a 90-degree clockwise rotation. But you could have written this as a 90-degree rotation clockwise. All right. Afterward, there's another way to describe this rigid transformation. Well, instead of going clockwise, why can't I go counterclockwise? If I went counterclockwise, I could go 1, 2. So instead of going clockwise 90, I could have gone counterclockwise 270. You could make this a 270-degree rotation. Rotation counterclockwise. Right. Now I just need to think and make sure if I did this right. Clockwise and counterclockwise is easy to mess up. I'm actually going to go to the other page for the clock. Clockwise is this way. And I move 90 degrees that way. Yes, and then 270 counterclockwise. All right, good. So yeah, these are really easy to mess up. Even I mess these up all the time. All right, now one last problem. So this is the graph of y equals x squared and its image displayed on the right. Write the equation of the image in the form of y equals. So x squared is this one here. It's kind of like, it's like bluish gray. The new one is this. Well, this is definitely a translation. It's moved right and down, but by how much? It moved right, 1, 2, 3, and down, 1. So this translation is right, 3, and down, 1. But I need to write this as an equation. So if you go back to Algebra 1, there was this wonderful equation called vertex form. So it's y equals x minus h squared plus k. So y and x are always in the equations. I need to find whatever this h is. I need to find whatever this k is. Well, h and k are actually this movement here. I've moved to right 3. You're going to put a 3 there. Down 1. You're going to put a 1 there. So I'm just going to fill these into the equation. So y equals, oh lovely, it's already here. Parentheses, x minus 3, squared plus 1. That's kind of funny. Like minus 3 usually means I have to go left. So why is this going right? This is okay though. So this is something that is going to follow you through all of your math classes. Almost every single graph does this. Whenever you have something with the x, and specifically in parentheses, it does the opposite of what you think it's supposed to do. Oh, minus 3 is supposed to go left. Nope, it goes right. So this does the opposite of what you think it's supposed to do. However, the number on the outside, it does what you expect. So, this is not just in geometry. This happens in Algebra 2. This happens in pre-calculus. This keeps happening over and over in your different math classes. So take this skill with you for the rest. All right, that's everything, and that's it.